All right, good morning, folks. There are a couple of piles of handouts going around, so those should be making your way to you. But let me give you the background. We're essentially going to group up with another person in the class today. You're going to be doing a peer review. So you're going to be talking about your ideas for your story map project. You've all done your story map proposals at this point. And the first thing that packet will ask you to do is kind of sketch your map. Like, what do you expect it to look like? What types of symbols do you think you're going to use for your data? What is the spatial extent, the scale? Add a title to the map too, right? You want to make a sketch so that the person you're teaming up with has a good sense for what your story map is going to look like. Once we finish that, we're going to start talking to person next to you, person behind you, whatever. Everyone needs to group up with at least one person. And you're going to provide feedback on the various aspects of the story map proposal for your partner. So constructive feedback, right? We're not just looking to poke holes in each other's projects. We're saying, hey, have you thought about this? Oh, I like what you're doing here, but maybe this could be improved in a certain aspect. Does that make sense? Any questions? All right, so hopefully those packets are making their way around. Raise your hand if you still need one. Couple people. If there's some extras floating around, I can grab those. So yeah, let's take about 10, 15 minutes to draw your map. No? If you're just coming in, I've got a handout for you. Good morning. Yeah. Hello. Interesting. That's great. Yeah. Some cities might have better data than others. You know, some cities might actually have like, here are trees. Or use satellite data.
Yeah, well,
Or and then looking at like the demographics and income of
Yeah.
the people who live around those places. Yeah, it sounds like a great idea. There. Yeah, for sure. So it's possible that some people might be finishing up their drawings. If once that occurs, just pair up with someone. Hopefully we have an even number of people. Otherwise, we can have some groups of 3 as well. And you can discuss your ideas and solicit some feedback. On that second page, so just to remind you that the first page, to get some credit today, I want you to rip off this first page, make sure your name's on it. You're going to turn that into me before you leave. But the second page, you're going to actually give to your partner with your feedback about their ideas. So you can start discussing if you finished your drawings. If you need more time for your drawings, you can totally keep working on those as well. So oh, wow. Yeah. Nice. Yeah. All right, thanks.
Yeah, they go pretty far, like no. You had a question of like, you think you see this story map page for like inspiration?
Yeah.
And I guess we were just wondering if ours is actually gonna be kind of like this, when we're gonna have like, where we could make like multiple times, it's not just me like that.
You can, but you don't necessarily have to. Like, I don't expect this level. I mean, some of these are like
Yeah.
entire research groups working for months, you know. So some of these are in a level that I don't expect. But just kind of some themes,
But it doesn't just have to be like.
it doesn't just have to be one map. That's kind of the basic requirement is one map. If you
Yeah.
want to have multiple maps or
Yeah.
graphics,
Okay.
go crazy.
Yeah. How to reduce traffic along one street by yeah. Yeah. Nice. I thought. Oh, nice. Yeah. I spent a long time down. Yeah. What board did you have? Yeah, sure. Okay. Okay. I just know there's a girl on this board that doesn't like this. I know Gianna. I'm not 100% sure that. But I still Gianna is there. It's up there. It's not this summer. Yeah, she is. But yeah, yeah, if you look at the albums on the floor for it. Yeah. Oh, yeah. That's good. They probably. Yeah, this, yeah, I'd say also that's a lot. Yeah. And so,
That's an extra block. And then you already want.
Yeah, that's. So I was getting that. Doing this combination of like, so I'm going to take the data points of like what, and what, and then the combination of, right, is basically loss. But that also could be all your odds that go with that, one for
Yeah. Oh my God. I just like the first part.
Yeah.
All right, let's put on 5 more minutes to finish this up. So 57 after, we'll finish up.
Like maybe if I just like.
Yeah, but that's.
I think it's weird, but because I like I'm only learning. So.
That'd be cool. Yeah. Yeah, no, yeah. That's basically the question. Yeah. Actually, it's like. Yeah, it needs conciseness, like. Yeah. This is concise. It's like. I like to say just like. Very. He knows we're all, so we're technically. So don't you know you're not.
All right, let's start wrapping this up. Thanks everyone for your participation. Remember to take that back sheet and hand it to your partner so they have it to reference. Hopefully they get some good ideas out of this. And you're going to turn in that top sheet on your way out. So we can start one pile on this front desk on the right side on your way out, and the other side is there as well. Don't take off just yet. I got some more stuff for you. I think that was useful, getting some feedback. I think it's always great to get another set of eyes on your ideas. You know, one example of a map that I think is a great concept, kind of fun, is this map of beer versus wine. So I like to just look at maps, think about how we might make them better, think about what's good about these maps. We talked about design strategies last time. And so this map uses a data set that has spending data on beer versus wine. And the cartographer chose pretty logical colors for these beverages, right? Kind of a red wine color on the right side and a kind of wheat beer color, lager color on the left side. And this one shows some nice trends in the data. Does any region really pop out as favoring beer over wine based on this map? Midwest, kind of. There's like a north-south line right through the Dakotas, right? Kind of takes a left turn up into Montana as well. Lots of beer drinking in Montana, of course, especially on game day weekends. And then the coast, right? We're seeing some really pink hot spots, especially in like the more wealthy areas on the coasts. You might expect Napa Valley region in California to have a strong preference for wine. The county that contains Denver right here really jumps out. But I will also highlight here, because I know how this map can be improved, there's some areas that, you know, the 50-50 point kind of looks pinkish, right? It might be a little bit misleading. So if you just mix these colors on a scale between each other, if you mix that yellow with the purple, you get kind of a pinkish color right at that 50% mark. And that pinkish color, I think most people would associate more with wine, right? Rather than beer. Unless you're drinking some kind of raspberry sour or something. So how could we improve this map, right? Let's change the color scheme a little bit. So just a slight tweak here. We've set up our color scheme to have stops and a third color in there. So the cartographer probably put a stop at like 60% where that yellow gradient stops. It's taken over by a gray white tone to represent like no strong preference either way. And then we have that purple pickup on the other side of the spectrum. So just a small tweak. I think a great example of how little changes in your design strategy can tell a much more effective story. What we can tell here is that the geographical area covered by people who prefer to drink beer, spend more money on beer, is definitely greater than that of wine. But there are some hotspots, again, major urban areas, particularly in the Northeast, that spend a lot more money on wine. So for other cool map ideas, you know, adventuresinmapping.com is a great resource. I also pointed you to the story map gallery. I had a student come up and ask me a good question I wanted to share with the rest of you. You know, this peer review activity asked you to sketch one map. And that's sort of the base requirement, right? We want to have at least one map on your story map. We want to have some contextual information, like what is your question? Add some text there to explain anything the reader needs to know to actually interpret the map. Cite where the data came from. So you want to use a proper citation format. You can look up like MLA or AP style to make sure you're citing web pages appropriately. But yeah, you want to actually reference where the data came from. But what I'm getting at is you need to have one map. You can have more maps as well. Like if you're trying to tell a story that needs 2 or 3 maps, you want to turn different layers on, you want to symbolize them in a different way, feel free to add multiple maps. You can add graphics if you would like. There's lots of cool things you can do. At the same time, I don't expect these to be as good as those story maps that are in that gallery, right? A lot of those represent work by teams of people over multiple years. Not something that's achievable in the span of this one semester. So, you know, don't feel like you need to make like an amazing map worthy of inclusion in that gallery. Any questions or comments? Right. So in the last 15 minutes of class today, I want to talk about symbolization strategies. This is part of the design process. And specifically, I want to introduce some terms that you maybe have heard before, but probably haven't heard before. And it has to do with the nature of the data set you are working with. And the nature of the data set is really going to control what types of symbolization strategies you have available to you. So that graph on the left, kind of a busy graph, but it shows you how for point, line, and polygon data, you can vary 4 different categories of things to achieve different symbolization styles. So you can change, you know, keeping the color constant. We could add color to this list. You can change the color, the shape of the symbols, the size of the symbols, or the line weight, and the spacing of any sort of pattern fills. And just summarized on the right side is that different strategies are better to apply to different types of data. So we've got different categories here: ordinal, interval, and ratio data. These are all types of quantitative data sets. We'll discuss what the difference is between those. And then pattern and shape. So like using a triangle instead of a circle, using a different pattern fill, using a different color. This is better to use in conjunction with nominal data or qualitative data. So I want to walk through what each one of these is. We're going to start with the qualitative data types. And we'll start at the top of this list with nominal, right? So one example of nominal data is something like a zip code or a phone number, right? There's actually no quantitative meaning to the number. It's just, you know, John Ander has a phone number of 555-6769. There's no reason to add or subtract phone numbers with each other, right? They're not quantitative data. It's kind of just a label that identifies a feature. So bounce it over here to a map in ArcGIS Online. And if you want to follow along in ArcGIS Online, what you can do is just open up Map Viewer and add this layer here, USA 2020 Census Population Characteristics from Living Atlas. Otherwise, you can just follow along on screen. Let's take a look at what the county data table has available to us. And specifically, I want to find a, sorry, slow browser here. I want to find a field that is nominal in this case. And there's actually a lot of them to work with. So hopefully you can read these field names down here. But even just the first attribute field in this table is called the county GNIS code. And it's just a numerical code that identifies a county based on some geographic identifier. Next column over here is the same, right? Geographic identifier. This is just some nominal data. And so if we were to symbolize based on one of these nominal fields, it could also be something like county name, right? Gallatin County, Jefferson County, whatever. Butte, Silverbow. These would all be considered nominal data types. And you would have different options available to you for symbolization. So in ArcGIS Online, if we want to symbolize based on a field, of course, the first step is under the Styles pane. You just click that field button, and let's choose one of these nominal data types. ArcGIS Online is actually smart. It recognizes that this is nominal data because it's probably stored as a text field. More technically, this would be a string field. And it only gives you two options. You can use unique symbols, or you can plot everything using the same exact symbol. Because there are so many unique counties in the nation, it's really not feasible to use a unique color for each one. So instead, in this case, you might just choose a single symbol and then go to labels. We might add a label class here. Let's use the name, and let's set it up to only show those labels at a higher zoom level so the map doesn't become super busy. We might want labels to show up at this zoom level. Drag that slider, and now we can see the individual name of each county. So that's nominal data. Ordinal data is a ranking. So again, we can have numbers in this data type. You know, one good example is like the order of finishers in a race, or maybe with census data, it could be something like, is it a micropolitan area? Is it a metropolitan area? Is it a major urban area, et cetera? We have some rankings based on thresholds, but we don't have enough information to be really quantitative about it, right? If you were considering metropolitan area as anything over 50,000 people, or some other number that defines that class, we would know that maybe it falls into that category, but not the exact number. That would be considered ordinal data. So jumping back over here to our counties. Let's scroll through the fields. There's actually a couple of different ordinal data sets in this census data. One is called current class code, and another is called current functional status. And these are actually rankings based on the type of the community in that county. So whether we have largely urban areas, right? Los Angeles County is going to be very different than Gallatin County in its makeup. And there's sort of a ranking. I can't actually see behind this thing, so let me pull up this web page. So for instance, functional status code A, this would be like an area with active government, providing primary general purpose functions. B is active government that is partially consolidated with another government. So there's sort of a ranking here, and those codes aren't just nominal. They have some implied order to them based on some underlying metric. Maybe not the best possible example, but you know, a couple of different ordinal data sets do exist in that census data. All right, now let's jump to quantitative data. So the two trickiest data types that I expect you to know are definitely interval and ratio. The difference between these is that interval has no true zero. The data is quantitative. Excuse me. but a value of 0 does not necessarily imply an absence of that phenomenon. A good example of this is pH, right? Or temperature. Like a temperature of 0 on the Fahrenheit scale does not mean there is a complete absence of temperature. It's just an arbitrary 0 on a quantitative scale of temperature. Same thing with pH. We can have negative numbers, we can have 0, but if you have a pH of 0, you still have a pH. Ratio does have a true 0. So this could be a measurement of length. It could be a measurement of the total number of people who live in your county. It could be a measurement of snow totals or rainfall totals, right? 0 truly does imply that there is no rain in the area. It's an absence of that phenomenon. So let's see if ArcMap is working here. And let's go find an attribute field that actually is interval. Sorry, actually is ratio in this case, having a true 0. I actually couldn't find an interval data set in the census data. Let's see how ArcMap responds when we choose a quantitative attribute field with a true 0. So I'm just going to choose total population in this case. And our symbols pane is going to update with a few different options for us. And in this case, we've actually got a lot of different options. Down here at the bottom, it wasn't able to figure out that these are ratio data, right? It still offers us the opportunity to have unique symbols. This would be a really bad idea. You do not want an individual color for every single difference in population across the entire United States. It's probably pretty obvious, right? However, the top 3 or 4 options are probably all good for ratio data. So the default here is just a graduated symbol strategy. We can tweak these options a little bit. We can actually set the sliders to be nice round numbers, like 1 million. We can drag them to change how our symbols behave to kind of make the populated regions pop. You know, if we just want to highlight one range in our data as being part of that size gradient, we can do that. So a lot of options available to us with this quantitative data. And then finally, cyclic. This is something like time, or you can imagine like a slope aspect map showing us which direction the slope is facing. Really important for like snow science, understanding ecology, where forests might grow, where different species might grow, etc. So it is numerical. You can add and subtract the values from each other. Like it could be a 0 to 360 scale, but they repeat within a set range. So for the case of an aspect map, that would be 0 to 360, and you can't have any number greater than that. So that'd be an example of cyclic data. All right, quickly, some examples, right? Snow stake from Steamboat, Colorado. There's actually 2 different data types here. One is ratio. Who can tell me what is the ratio example in this case? Snow stake, right? You can have 0 snowfall. A little bit on the tree there, but nothing on the actual snow stake. So that has a true 0. But temperature up here, that is an example of interval data, because the 0 does not refer to an absence of temperature. We can symbolize these data in different ways, right? Ordinal rankings of finishers in a race, etc. And next time we'll do this little thought experiment where we think about trees and we come up with a data type we can measure for trees for each of these different data types. All right, so make sure you turn in that front page to get credit. Make some piles on the front desk up here. Have a great day.